everybody. In this video, I want to get into some of the smaller details of scatter plots and line of best fit and really try and tackle this question I've written at the top is how good is our line of best fit? So how do we know our line of best fit was a good choice? And really, how do you know that, right? So first we're going to start off with just residuals. What a residual is, how you calculate it, those things. So when you have a scatter plot with a line of best fit, like I do here, what we can do is we can calculate a residual. So the calculation here is you're going to take your observed y value and subtract your predicted y value. So you take your observed y value and subtract your predicted. So your observed is just what happened in the data. When you recorded your x and y data points, that is your observed data point. The predicted y value is just, well, if you take an x value, so say, I have some data point that said, hey, x was 20, y is 30. This y value here would end up being my observed data point. What you do is you take this x equals 20, plug it into your line of best fit to generate a predicted y hat, a predicted y value. So you're going to take what actually happened and subtract off what our line predicts what will happen, and that will create a residual, okay? So here's what a residual is. It's really looking at the vertical distance from a scatter plot point to our line. So if I had this line right here, this point, it's measuring this distance from this point to this line and saying, how off were we? So how off was our observed value from our predicted value? So if you're taking observed minus predicted, and if your observed points are above, you're going to get a positive residual. What that means is what we observed as happening is better or higher than what we predicted happened. So our observed value is better than our predicted value or bigger than our predicted value. Depending on the context of the situation, that could be a good or a bad thing. Since we're doing observed, subtracting off our predicted, which again is our line, if we had this point here, that's what the residual would look like, that vertical segment there. This is going to give you a negative residual, And if you have a negative residual, that means our observed data point was below or came in lower than what we predicted would happen. Now, again, with context, who knows if that's a good or a bad thing? Maybe we want to come in lower than our predicted. Maybe we don't, okay? So the context and the interpretation of residuals is any data point that is above our line of best fit did better than our prediction, and any data point that is below the line did worse than our prediction. Any data point that falls on the line, that means we ended up right as predicted, okay? We hit our prediction, okay? So that is residuals. Now, what we can do with those is we can create residual plots. So what it does is it takes each of these individual residuals and it makes another graphical display of them. So what you're going to see is you're going to see a horizontal line that represents a residual of 0. Positive residuals will be above, negative residuals will be below. Now, typically, the axis across the bottom is going to be the same x-axis up here. It can change, so you want to pay attention to the problem, but typically it is the same. So here's the purpose of the residual plot, is it allows us to additionally try and answer this question of how good is our line of best fit. So what we're looking for is we need to see chaos. We don't want to see any clear pattern, okay? And we talked about this in class, what type of patterns you see and what they mean. But as a quick overview, we're looking for a chaos. That typically is going to support your idea that a line of best fit was a good choice, okay? Other ways we can try and figure out, is a line of best fit a good choice? And we have these two pieces at the end. A correlation coefficient that is represented as R. What this is going to do is it's going to tell you the strength and the direction that your line of best fit is going. So it's going to tell you strength and direction. Here's how it works. Your correlation coefficient R is usually going to be some decimal, but it can go from -1 all the way to +1, somewhere in between. As far as strength, the closer you are to 1 or -1, the stronger your fit, aka when you have your line of best fit, the data points are pretty darn close to that line of best fit, a very, very tight cluster. The closer you get to 0, or the center of this, the weaker it becomes, the more spread out your data points are, okay? So strong at 1, strong at -1, weak if you're closer to 0, okay? So you're either going to need to gravitate towards the 1 or gravitate lower to the -1 to get stronger. 0 is what's going to be, hey, we're very weak. Additionally, is direction here. It's going to tell you whether your scatter plot or your line of best fit is going in a positive direction or a negative direction, going up or coming down. If your correlation coefficient is a positive number, that excuse me, that's going to tell you we're heading in a positive direction so that we have a positive slope. If your correlation coefficient is a negative number, that tells you your scatter plot is trending in a negative direction. Your line of best fit is going to have a negative slope. Okay, so all three of these together are going to help you answer the question is, how good is our line of best fit, or is even a line appropriate for our scatter plot? So there's three things you want to check. One thing you want to check is, as I have that scatter plot, does it look like it is a line? Okay, so just look at your scatter plot. Does it look linear? That's the first thing I would check. The second thing I would check is, if I have a residual plot, does it look chaotic? Okay, so I check my scatter plot, that shows linear. My residual plot, it shows chaos, so that supports that a line of best fit is a good idea. And then finally, I would check my correlation coefficient once I've generated everything, and I would see, is it strong and is it positive or negative? If it was weak, then I'd be like, I don't know. Okay, so we're looking for strong correlation coefficients, chaos in the residual plots, and when I fit my line of best fit to my scatter plot, does it look like linear is a good choice? Okay, all three of those together are going to answer the question of how good is our line of best fit, and is a line of best fit appropriate here? The final question I want to get at here, the final little piece I want to touch on, is a coefficient of determination, which is going to be represented by r squared. It's kind of the forgotten piece of the nitpicky things in this section, but I just want to cover it quickly here because, yes, it is related to the correlation coefficient r. So if you know r, square it, you get r squared. If you have r squared, take a square root, you now have r, but be careful whether it's positive or negative here. You're going to need to pay attention to that slope to know whether it's a positive or a negative for r. So the coefficient of determination, what it's going to do, it's going to talk about that relationship between x and y. You know, how good of this relationship between x and y. So it's going to talk about the percent of y that can be explained by x. So how much is the change in y accounted for whatever is happening with x? Does x really affect y that much? Because that is what we're trying to figure out here in our studies. We're trying to figure out, is there a relationship between x and y? Because if there is a strong relationship there, then holy cow, we can make some pretty solid predictions and messing around with x to try and get our ideal y. So that is our goal. You know, if I knew, you know, I used in my other video, number of hours studied for x and say a score on the test for y. If I had plenty of data there and everything points to number of hours studied directly correlates and will affect your y, then I might start exploring the idea of, well, hey, if you study this many hours, you might get this score for y, okay? And we got to do a little bit more to talk about cause and effect there of, hey, does the number of hours study actually cause a certain grade in that? And that's a future unit we do. But we start exploring that idea and say, hey, this is something I want to look a little bit closer at, the number of hours studied for a test and my test score, okay? So this was a quick overview of how good is our line of best fit and the things you need to look for. So this is, both my videos, a general overview of line of best fit, so hopefully you feel refreshed and know what's going on in this unit.